Today we're going to talk about two different types of ways that we can say two triangles are congruent. So yesterday we were just looking at pictures and saying these two triangles are congruent and we can match up all their parts and then those parts will be congruent. Today, instead of just saying like they look like they are, we're going to use some facts to say that they are. And we're going to use two postulates to do that, and those postulates are called side, 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 and side, angle, side. We abbreviate those because that's a lot to write, so we just say SSS and SAS by their first letters. These are both postulates, which means that we can't prove them, we just accept them. So the first postulate says if three sides of one triangle are congruent to three sides of another triangle, then those triangles are congruent. And that's our side, side, side. That we're matching three sides in one and three sides in the other. And that means that the whole triangles are congruent, which means that really the angles are too, even though we weren't given any information about the angles. Our second postulate says if two sides and the included angle. So a picture will probably be helpful for you on this to know what that means. So when we're talking about side, angle, side, we've got two triangles that have two sets of sides that match up. And then it says the included angle. The included angle is the angle between the sides that we know about. It's the angle that makes those sides. And it has to be that one. One of the other angles isn't going to work for us. We have to have a side, and then an angle, and then a side, all connected to each other like that. Okay? And it says if we have that, then those two triangles are congruent, which means that all the parts that we didn't really know anything about, those parts have to be the same as well. The reflexive property is going to be really important to us in our proofs today. Somebody remind me what the reflexive property was.
Something is equal to itself.
Something's equal to itself. It felt like kind of a silly one when we learned it a long time ago because of course something's equal to itself. But that's going to actually be something important for us in these proofs because often, like our pictures yesterday, the triangles are going to be sharing a side, and that side is going to be one of the important pieces that we need to use these postulates. So you're not going to use the reflexive property in every proof, but you're going to use it in a lot of your proofs today. So our first one, all right, given's a good place to start. So I'm going to start by saying my given, that AB and CD bisect. Oh, we're doing proofs and only proofs for about the next 2 weeks.
Oh,
Same. Joker's
One question that I ask myself a lot when I write a proof is, okay, so what does that mean? So if AB and CD bisect, what does it mean to bisect?
At the middle.
They intersect at the middle. So it's a special kind of intersection. They're intersecting each other right in the middle, which means that we get some equal pieces. So AM should be equal to BM, because M is in the middle, and CM should be equal to DM, because M is in the middle. So that's what we want to say next, is that we get some congruent segments. Our reason on that is the definition of bisect. That's what it means to bisect. So whenever we can use that phrase means to, that's a definition. That's what it means to bisect, is that it cuts them into equal pieces. We are asked to prove two triangles are congruent, and that's what you're going to be asked to prove in all of your problems, and we only know 2 ways to do that so far. Over the course of the next several lessons, we'll be learning more ways, but today we only know 2 ways. We know side, 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 and side, angle, side. So far we have 2 sides that we've said, so we need to either be able to say the third side, or we need to be able to say an angle. So what else can we say about this picture?
Angle 1 and angle 2 are
Angle 1 and angle 2 are congruent. Why?
vertical.
Vertical angles. So now I have 3 things marked in my picture. I've got 2 sides, and I have the angle that's connecting those sides. So that means I have what I need. So then I can finish this out by saying the triangles are congruent. Yesterday you had to come up with the names all by yourself. Today you're given the names because it's the proof, so you don't really have to think about the order of the letters today. And our reason is side, angle, side, because that's what we know in our triangles. Questions?
Side angle side, I'm not quite sure what that means.
Side angle side is that second postulate that in each of these triangles, I have one side matching one side, a second side matching a second side, and the angle between them are matching as well. So it means side angle side that is given in each triangle as matching up. So that's going to be a goal for today, is either a side angle side or a side side side. That has to be our last reason in saying that our triangles are congruent. And so before we can say that, we have to get those pieces of information together. So for our second example, I'm going to start with the given. That's a good place to start. And I always like to mark up my picture so I can see what I have so far and know what else I need to do. So RS and RQ, and ST matches TQ. So far we have 2 sets of sides. To be able to say 2 triangles are congruent, which is always the goal for today, I have to either get all 3 sides or 2 sides and the angle that connects them. So I need one more piece of information in here. What can I say about these 2 triangles? RT is congruent to RT. RT is in both of the triangles. And so it works for both, and it has to be equal to itself. Why? Reflexive. Something always equals itself. That's our reflexive property. Now, how did we know that it should be RT-RT and not like RT-TR? Because that actually makes a difference. So how did I know that I should write those letters exactly the same way?
They have to be matching.
Yeah, they have to be matching. So our goal is think about this picture and how can I make these 2 triangles land perfectly on top of each other? And I would do that by folding the picture closed. And if I fold the picture closed, everything's going to line up just right. When we have a folding, the letters should maintain their order. Okay? You can also tell by looking at your triangle names and noticing that R and T are in matching positions. So when that happens, that they're following the same matching positions, then they should be named the same way. Visually, it's because those triangles are folding closed to be able to land on top of each other. Alright, so now we've got 3 pieces of information marked in the pictures, so we can now say our triangles are congruent. And which reason would we use?
Side, side, side.
Side, 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 because that's what we know, is we know all 3 sides of one are the same as all 3 sides of the other one. Alright. Questions? Alright, so start with the given. It's a good place to start. And I like to mark my picture. So BY and AX, EX and AY. So 2 things marked. We always need 3 to be able to say that our triangles are congruent. So I need something else. What else do I know about these 2 triangles?
The line in the middle. Well, wait, no.
Nope, you're right on there. The line in the middle is in both of them, right? The two triangles are sharing one piece. They're sharing that center line. Now, when I name that center line, am I going to want the letters to be in the same order or in backwards orders? How can I tell?
Because if you fold it, it doesn't.
If I fold it, stuff isn't going to line up right. I would have to take that top triangle and turn it around to make it land on top of the bottom triangle. And so this is a turning problem, which means that our letters are going to end up being backwards. Another way we can tell is from our names. In the triangle names, they come in the order XY in one name, but YX in the other name. So we're going to say that XY is congruent to YX. The reason it's still reflexive, even though the letters are backwards, is still the same side. It's just naming it backwards. Anytime that you have a turning is when the letters are going to be backwards. If it's a folding, they'll be in the same order.
Can you frequently tell just by like the given if it's gonna be like reflexive or if it's gonna be the same?
You can't necessarily tell by the given, but you can tell by the proof.
Oh, the proof.
If you look at the triangle names in the proof and look for are the matching letters in the same order, are they backwards in the two names? So now we have three things marked up. So now we can say that these two triangles are congruent. So triangle BXY and triangle AYX. And which reason would we use?
Side, side, side.
Side, because that's what we know. We know all three sides. That's what we have marked as three side congruences. Alright. One more example. Start with the given again. This given's a little bit different. We are given one set of matching sides as being congruent, but then our other given isn't that two sides are congruent, it's that they are parallel, and it's actually the same two sides. So we know those sides are parallel and congruent. When I am given information about having a set of parallel lines, and there's a lot of lines in my picture, what I like to do is make myself a little drawing off to the side that shows just the parallels and one other line, which is typically going to be like the line that's going down the middle of the figure, the diagonal line. The reason I like to do that is it helps me single out some important angles. If these two lines are parallel, this is a very special angle pair for us that we learned about in our last chapter. What kind of angles are those? AIAs, alternate interior angles. And we learned in the last chapter that if we have parallel lines, AIAs, or alternate interior angles, should be congruent to each other. In our picture, that would be the same thing as those angles. Now, I'm going to name those as being congruent as my next step, but I can't just call them angle X and angle Y because there's too much stuff happening there. There's no numbers in the picture, so I'm going to have to use three-lettered names. So I'm going to call the lower one angle AXY, and the upper one then would be angle BYX. And our reason those are the same is if parallel, AIA are congruent.
Does it matter if you use AXY or if you use AYX, like the other alternate interior angles?
It does. It does matter because the other alternate interior angles, the ones that you're referring to there, so change my color here. The angle AYX and YXB, those are also alternate interior angles. But if I draw those out, the picture looks like this. They are still alternate interior angles, but I don't know that those two lines are parallel, which means that I don't actually know if those two angles are congruent or not. So it does matter which set of alternate interiors you use. Good question, because a lot of students will pick the wrong ones. That's why I like to make that little drawing off to the side that shows just my parallels. So I make sure to grab the right set. All right, also remember from the last chapter, it's important that you say that if parallel, because if they're not parallel, then our angles aren't congruent. So we can't just say AIA. That's not enough. Okay? AIAs exist all the time, but we can only say they're the same if we know we have parallels. All right, so now in our picture, I have 3 things marked, but really only 2 things count. Now I erase out those red ones so they don't distract us here. So I have 3 things marked. I have a set of angles. I have a set of sides congruent, and that set of sides is parallel, but parallel doesn't help me with SSS or SAS. So I need something else. I need 3 things congruent. So far I have 1 set of sides congruent, 1 set of angles congruent. I need something else congruent before we can finish this off. And so what is that going to be? YX and XY. That middle line again is going to be congruent to itself, and again the letters are backwards because it would take a turning or twisting to make the 2 triangles line up with each other. Our reason on that is reflexive because we're saying the same side is equal to itself. So now I have 3 things marked as congruent in the triangle, so I can say the triangles are congruent. And which reason would it be? SAS. Because that's what we know. So we know 2 sides, and we know the angle that connects those sides. Okay. 3 to 4 steps, all your proofs today. None of them have to be longer than that. 4 is the longest. 3 to 4 steps for each proof. You also can't do it in 2 steps. Okay, so you're going to have at least something in there. Maybe it's just a reflexive, but you can't prove it in just 2. So all your proofs today are going to be 3 to 4 steps. Your proofs are going to come from worksheet F, which is in the packet from last night. But you just flip it over, and it has a big, handwritten F in markers there. I like to mark up my pictures, but you're going to keep on reusing the same picture for multiple problems. So if you're marking up your picture, you probably want to be doing it in a pencil or kind of redrawing it on your paper because you're going to use the same picture for multiple problems. And tomorrow night's problems are going to come from worksheet F as well, which means that just because we're not doing a problem tonight, don't cross it out because we might be doing that problem tomorrow night. Okay?